In this video, I will demonstrate the correct procedure for conducting a direct shear test on a loosely consolidated drained sand and discuss the results. The procedure followed is outlined in ASTM 380. The first step is to assemble the shear box. 2 shear pins connect the halves. The shear pins should be finger tight. The second 2 pins are what's called gap pins. Gap pins will eventually lift the top half of the box a small amount to prevent friction between the 2 halves. The gap pins should be tightened after the shear pins. Here I am placing the bottom cap. The bottom cap is slotted for draining. The ASTM does not specify which direction the plate should be oriented. The next step is to insert the load transfer plate. The vanes should be perpendicular to the direction of shearing. When preparing a loosely consolidated sample, air pluviation will be sufficient. It is important when preparing a loosely consolidated sample that it is done in the shearing apparatus. However small, the sample may be consolidated upon being set down. Air pluviation is done by slowly releasing sand into the box via funnel. Weigh the remaining soil to determine how much soil is in the box. Take a sample for water content. Now place the top load transfer plate on the specimen in the same orientation as the bottom. Place the top cap on. Set the screw stop so that no load is transferred to the specimen. Determine how much weight will be needed to apply the desired normal force. Be sure to include the weight of the hanger. Put the weight on the hanger, then apply the load. If using the lever arm, ensure that the load is level. Perhaps the most important step is removing the shear pins. Once they are removed, then twist the gap pins about a half a turn. Record the sensor readings and begin the test. Record the data. Perform the test multiple times with varying normal loads. After performing the tests, enter the data into Excel. Note any units and convert as needed. Determine the shear force, alpha, corrected area, normal stress, and shear stress. 3 graphs will need to be made. The first is the shear stress versus horizontal deformation. The second is vertical deformation versus horizontal deformation. The third is shear stress versus normal stress with one caveat. The caveat is that the data presented on the graph is the maximum values at failure. If 3 tests were performed, then there should be 3 points. Construct a line of best fit and display the equation of the line. The first term is the slope. Take the inverse tan of this to obtain the apparent friction angle. If there is a second term, then it technically represents cohesion. However, if this test was performed on a cohesionless soil, there is no cohesion, so that value is likely due to the friction between the gap pins and the shear box. The primary disadvantage of a direct shear test is that it predefines the failure surface. The benefits of the direct shear test is that it's typically cheap to facilitate and it is relatively quick.